Good morning. We're going to start our combinations videos. I am hoping that you watched all of my probability videos, tree diagram videos, permutations 1, permutations 2, and we're starting combinations. If you remember, we talked that for permutation, order matters. That's when people come in first place, second place, third place, when gold, silver, bronze, president, vice president, treasurer, if those are your top 3 people. Now we're going to do combinations where order is not important. So if you look at number 1, in how many ways can 3 representatives be chosen from a group of 9 people? So that means I'm starting with 9 people and I'm going to pull 3 of them. And in the end, I'm just going to have those 3 people, but it doesn't matter who I chose first, second, third. Okay, there is a formula for combinations, okay? This is a combination. I'm starting with, 9 people, sorry. I'm starting with 9 people, and I'm going to pick 3 of them. Okay, so that means 9 people, 3 slots. Watch what you do. 3 slots, okay? I'm picking 3 representatives. I could pick 9 people first, then 8 people, then 7 people. But if you think about it, if I choose Charlie, Bobby, Cindy, right? If I choose Charlie, Bobby, Cindy, those are the same 3 people. Oh, let's do Charlie, Bobby, Anna, sorry. Those are the same 3 people if I choose Charlie, Anna, then Bobby. Or Anna, Bobby, Charlie. Or Anna, Charlie, Bobby. Or Bobby, Anna, Charlie. Or Bobby, Charlie, Anna. All these different ways really represent one way that I'm going to have these 3 representatives. So what you do is you have to subtract out the repeats. These would be repeats because it represents the same 3 people in the end. So you know multiplication is repeated addition, division is repeated subtraction. I am going to subtract out or divide out my repeats by taking this number and doing factorial. Remember factorial. Okay, I'm picking 3 people. I have 9 to choose from. 9 people, I pick 1, then 8 people, I pick 1, then 8 people, then 7 people, I pick 1. Okay, multiply. Now I can do my shortcut. 2 goes into 8 4 times. 3 goes into 9 3 times. 3 times 4 is 12, and my denominator is 1. So there are 12 different groups of people. There are 12 different ways. Out of 9 people, I could get different groups of 3. I subtracted out my repeats. Sorry, I thought you could see that. Okay, that's my final answer. So that's what we're going to be practicing for this lesson. Number 2. So notice number 1, we dealt with people. Number 2, we're dealing with food. Okay, so here, listen, I'll give you my opinion. When I make a pizza or order a pizza, order really does matter for me as far as what I might like first on my pizza, second on my pizza, third on my pizza, but we're gonna pretend here that we're not being picky and order does not matter. So this is a combination. I have 10 toppings to choose from total, and I'm going to choose 4. Here's the formula. I have 4 slots, okay? So I have to let Lucas sit over here. Come on. Okay, I have 4 slots, 4 toppings I'm choosing, but I get to choose from 10. 1, 2, 3, 4 toppings that I'm choosing. I have 10 toppings to choose from. I choose one. Then I have 9 more to choose from. Then I have 8 more to choose from. Then I have 7 more to choose from. But I have to subtract out my repeats. And I subtract them out by dividing this number factorial. I like to do simplifying first. 4 goes into 8 twice, 2 goes into 2 once, 3 goes into 9 3 times. So 10 times 3 is 30, and 30 times 7 is 210. My denominator is 1. So I have 210 different combinations of toppings that I can choose. Okay, going back to people. How many ways can a 5-player team be chosen from 15 people? Okay, doesn't matter now. Your feelings might be hurt if you don't get picked first, but in the end, you're all going to be on the same team. This is a combination. I have 15 people to choose from. I'm choosing 5. Notice that I have my calculator here. I haven't used it yet. I might use it, but whether I use it or not, I still want to see this work. Some of you are handing in work and not getting credit because you're not showing me the work that I'm asking you for. Okay, so I have 5 players. 1, 2, 3, 4, 5. I have 15 to choose from. 14, 13, 12, 11. Over this number, factorial. Okay, I'm going to simplify first. That goes into 15 3 times. 3 times 3 is 1. 4 goes into 12 3 times. 2 goes into 14 7. Here's a hint. You're always going to end up with a denominator of 1. It has to. You can't get a fraction. All right, now I'm going to use my calculator. 7 times 13. Sometimes 13 times 3 times 11 is 3,003 different ways. Notice I used my calculator. Notice I showed all my work. Okay, so we're moving away from people again. And now we have colors in a crayon box. Okay, so 7 colors, 20 choices. I think you get it. Order doesn't matter, it's a C combination. 20 crayons to choose from, I'm choosing 7. I have 1, 2, 3, 4, 5, 6, 7 I'm choosing over 7 factorial. 6, 5. Okay. I like to simplify first. 7 goes into 14 twice, 2 over 2. Can you see if I'm sloppy? I'm going to get this wrong, right? If I scribble and write sloppy or work too quickly, I'll get this wrong. 5 goes into 5, 4. See, and I'm actually working too quickly. Haha. That goes in 3 times. Okay, I keep going to my denominators. 1 just makes my life easier. 20 times 19 times 3 times 17 times 4, and it looks like that's it. If I plugged all those numbers in correctly and didn't make a careless mistake, that's my answer. I want to backtrack for a minute. Do you remember when we did the permutation lesson, and they talked about a lock, right? We call the locks on your lockers combination locks, right? We call the locks on your locker a combination lock. But on your combination lock, the order does matter. The order matters. Your combination lock shouldn't be called that. It should be called a permutation lock. I really have no idea how people started calling it a combination lock. So when I teach this lesson in class, I usually have kids raise their hand and say, hold on, and they figure out that your lock is called a combination lock and that it shouldn't be called that. So that's some smart thinking right there. Okay, so just to recap for 1 second, for permutation, right, order matters. And for a combination, the order doesn't matter. Right. So here are some keywords. For permutation, sometimes people are lining up. If you are lining up, you know it matters who's first in line. If you are winning something, maybe you're winning gold, silver, or bronze. You know order matters there. Same thing as gold, silver, bronze is first place, second place, third place. I remember when I was in elementary school and kids wanted to be class representatives, the kid that got picked the most votes was the president. The kid that got picked the second most votes was vice president, and the third was the treasurer. Okay, they kind of didn't run separately. Okay, so anything that makes it where you're separated and order matters is a permutation. Some keywords for combination. If you're just getting in any kind of a group, another word for group is committee. Another word for committee is a team. Okay? So those are some words to help you figure out if it's a permutation or a combination. Okay, so just a few things if you want to pause this and read. This is just a good reminder. I think I have to sneeze. Excuse me. Okay, that's a permutation if you want to pause this and read. And I'm doing this because you all don't have a green book at home, but I also thought this was interesting. Excuse me. One last piece of paper that you might want to pause and read. Okay, so you might like this. I'm going to post other videos on combinations. I always encourage you to watch all the videos I post, rewatch them, take notes, pause them, and try the problems for yourself. You heard me let my dog in. Let's see. We got Mr. Lucas sleeping in his usual spot. Yes. And then we have little Miss Daisy always sleeping in her spot. Well, she's not. We're going to go hiking later in the afternoon. I hope you have a good day. Bye.